The simplest way to measure the amount of dispersion in a set of data is with something called the range. To get the range, you just subtract the highest value by the lowest value. So I'll write that right here. Or you could say it's the maximum value minus the minimum value. Now let's calculate the range for the population of all 5 family members. The tallest person in the family is 84 inches tall, and the shortest person is 56 inches tall. The highest value is 84, and the lowest value is 56. If we subtract 84 by 56, we get 28. So the range of the entire population is 28. Let's calculate the range for the sample. The highest value in the sample is 65, and the lowest value in the sample is 56. So if we subtract 65 by 56, we get 8. Oh no, wait, 9. So it's looking like the sample is less spread out than the population, meaning it looks like the numbers in the sample are closer together and have less dispersion. And it looks like the numbers in the entire population are more spread out and have more dispersion. The reason why the population has more dispersion is because the population includes 84, which is a pretty extreme value that's far away from the other values. And since the sample doesn't include 84, and it doesn't include that extreme value, it has less dispersion. So since the sample has less dispersion than the population, it ended up with a lower range. Now, what's another way we could calculate the amount of spread or the amount of dispersion? There's actually another way to calculate the amount of spread or the amount of dispersion that's better than the range. And first I'll talk about the problem with the range. Let's compare the ranges of these 3 sets of numbers. These sets of numbers might look a little bit strange, but I'm just using these numbers to make a point. Let's think about which set of numbers has the lowest dispersion and which set of numbers has the highest dispersion. Well, these three numbers are close together, they're only 1 apart. These three numbers are 2 apart, so these three numbers have more dispersion than these three numbers over here. And these three numbers are 3 apart, which is more dispersion. So as we go from this list to this list to this list, we're seeing more and more dispersion between these three middle numbers. Right here, the three middle numbers are 1 apart. Here they're 2 apart, and here they're 3 apart. And in all three sets of numbers, the other two numbers are 10 and 20. So the other two numbers don't change. So actually, because of the middle three numbers, this list has the lowest dispersion, this list has the highest dispersion, and this list is in between. Now, if the amount of dispersion is going up as we go from left to right, you might think that the range should go up from left to right. And let's see what happens. The range is just the highest value minus the lowest value. So the highest is 20, the lowest is 10. If we subtract 20 by 10, we get 10. Here the highest is 20 and the lowest is 10. And if we subtract 20 by 10, we get 10. And here if we subtract 20 by 10, we get 10. The highest is 20, the lowest is 10. When we subtract the highest by the lowest, we get 10. So even though the overall amount of dispersion is going up as we go from left to right, the range isn't changing. Even though these lists of numbers have different amounts of dispersion, they all have the same range. And that's a problem with the range. Sometimes even though the amount of dispersion is going up, the range won't change. It'll just stay the same. So in other words, it's possible for different sets of numbers that have different amounts of spread to all have the same range. And that's a problem with the range because we can see that even though these lists have different amounts of dispersion, the range isn't showing that that's true. So we need a better measure of dispersion. Basically the problem with the range is it's only affected by the highest and lowest values. It doesn't say anything about the values in between, but the lowest and highest values. So since it only shows the distance between the highest and lowest values, and it doesn't show the amount of dispersion between the middle values, that's a problem with the range. Now we'll talk about other measures of dispersion that don't have that problem.